This is the P1 OCR 21st Century Science Lesson 7 on plate tectonics. We're going to be looking at how plates move and how this leads to effects on the Earth's surface. So, to start with, plate tectonics is the theory that the Earth's surface, the Earth's crust, is actually divided up into roughly 12 giant slabs of rock which float upon the surface on the magma. And because of the heat coming through from the core of the Earth, the magma is in constant motion due to convection currents, and so these slabs, these plates, the tectonic plates, are moving around. Now, essentially they can move in a number of ways. Where two plates are moving apart, that's where we form our oceanic ridges, as we mentioned in the previous video. Or if plates are moving towards each other, either they can become fold mountains, where they push up to make a mountain, or if one plate subducts under the other, that can form volcanoes. And the third situation we can describe is where two plates are moving past each other. Now, in this situation, when plates move past each other and get snagged, this can lead to earthquakes. Plates pushing together, plates moving apart can form oceanic ridges. And here, fold mountains or volcanoes. So in a situation where two plates are moving past each other and get snagged, then this is going to lead to a build-up of stored energy. And that stored energy will build up and build up over months, years, maybe even decades, till eventually the energy in there, or the force, is so great that the snag is overcome, and there is a sudden lurch in the plates, all in one go. And at that point, when that sudden lurch happens, then a tremendous amount of energy is released. Now, that energy is released in the form of seismic waves. And we're going to look at two types of seismic wave. We're going to look at P waves, and we're going to look at S waves. Now, as well as being a destructive force that causes damage on a wide scale, and also can cause tsunamis. If the earthquake happens to happen under the ocean, that can lead to a tsunami, which can also be devastating. The earthquakes, P waves and S waves, are detected all around the world by a series of seismometers. So a seismometer is a device which detects earthquakes. Now, around the globe, there are seismometers in very, very many places indeed. And if an earthquake happens at one particular part of the Earth, for example here, then the waves that come out from that earthquake will travel all around the globe and be picked up by the seismometers. And it's the evidence from these seismometers which gives us an idea of what actually is underneath the ground and the structure of the Earth. So let's just have a look at the difference between P waves and S waves. Firstly, a P wave, or primary wave, is called a primary wave because it arrives first. And the reason it arrives first is because P waves are much faster than S waves. So they travel faster. And the type of waves they are called longitudinal waves. Now, a longitudinal wave is defined as if the wave is moving in a certain direction, then the vibration which is causing that wave is moving parallel. So the particles in the S wave are moving, if the wave is moving this way, then the particles that are causing it are vibrating backwards and forwards. And this is just like sound waves. Another way to think of P waves as in push waves. And you can consider if you lined up a bunch of people one behind the other and they all get each other a little shove on the shoulder, then the push would be transferred all the way down. And so that's how we visualize longitudinal primary waves. So primary waves, P waves, are longitudinal. The vibration is parallel to the direction that the wave travels. And when these arrive at the surface, so if you imagine this is a P wave coming through here, and there's a building on top of the Earth, then this will make the building move up and down. So P waves shake buildings up and down. Now buildings are designed to be strong in the vertical plane, so P waves don't tend to cause so much damage. The real damaging waves are the S waves. Now S stands for secondary wave, and they travel more slowly than P waves. And S waves are a transverse wave. So if the wave is moving in this direction, so if the energy of the wave is moving in that direction, the particles that are vibrating in the wave are moving at right angles or perpendicular to the direction of travel of the wave. So S waves are much easier to represent as the classic ripples on a pond type waves. And so as the energy of the wave moves this way, the particles are vibrating up and down. And if you think of your rubber ducky on top of your water, then the rubber ducky will move up and down as the waves pass. Now S waves, again, will pass through the centre of through the Earth as shown, but they travel slightly differently to P waves, in as much as S waves never get to the other side of the Earth. So if there is an earthquake here, P waves will be felt all over the Earth. So P waves will travel and be felt everywhere. But S waves will not be found in this region here. So P waves will reach everywhere, but S waves won't. Now, one key fact about S waves is they do not travel through water, or liquids, sorry. Do not travel through liquids. So the absence of S waves here in this region on the opposite side to the Earth that the earthquake happens leads us to believe that there must be a liquid part of the Earth's core. So the idea of the liquid outer core comes from the notion that, it comes from the evidence, I should say, that S waves do not reach here. And this is known as an S wave shadow zone, a place where S waves don't reach. Now, so this knowledge of the fact that S waves do not travel through liquids and they don't get to the other side of the Earth from an earthquake on this side leads us to believe that we have this liquid outer core. The other thing about S waves is they will shake buildings from side to side, and therefore they are much more destructive. Buildings are not designed to be strong in that plane. So S waves are the ones that cause destruction. So in the event of an earthquake, what will happen is, first of all, you will feel the P waves arriving, which will make everything jump up and down. And then sometime later, the secondary waves will arrive and they will shake everything from side to side. And that shaking motion is what causes most of the destruction. Now, the time between the P waves arriving and the S waves arriving gives you an idea of how far away the earthquake is. If the earthquake is nearby, then the P waves will arrive and the S waves will arrive just after. But if the earthquake is a long way away, then this gap between the P to S wave, or the P to S wave time lag, gets bigger and bigger. So in that way, seismologists are able to establish where earthquakes took place. Anyway, key facts again. Earthquakes happen when plates get snagged, and there is a sudden release and a lurch of the plates past each other, we release P waves and S waves. P waves are longitudinal waves where the vibration is in parallel with the direction of motion of the wave, and S waves which are at right angles to the direction of travel of the wave. Because S waves don't travel through liquids and therefore don't get to the other side of the Earth from an earthquake that happens here, leads us to conclude that there must be a liquid outer core of the Earth. One more thing I noticed I missed out, which is that we call these transverse waves. So waves which travel at right angle, where the vibration is at right angles, are called transverse. So P waves, longitudinal, S waves, transverse.